Okay, gang. So now that we've got the kind of the preliminary stuff out of the way, some of the miscellaneous stuff that I wanted to get done in this episode kind of finished, let's get that block done, or the addition of new blocks, which is really the heart of this routine, really. The first thing we need to do is take care of hooking in the operator new into our memory routines, right? Right now, when we call new, we get this call right here, and I'm just going to deal with the basic new right for that in this episode. We'll deal with the others a bit later on. So, from an object's point of view, the most logical place to put the addition of a block is in the memory pool class. You'll remember memory pool classes kind of general responsibilities include handling all of the memory blocks that exist, right? You can't do it in memory block class because memory block only knows about its own block. It doesn't know about any of the other blocks. So when you're adding a new one, you need to do it through memory pool. But remember, in a global sense, the only thing that we really have access to is the memory manager class. So we're going to have to do a pass-through to go from memory manager into memory pool. So given all that, let's put in our hook first. Now remember, new needs to return the address of the pointer that it has set up, right? So I'm going to change this to something a little more descriptive. Right location. That's where we're going to end up returning. We'll go ahead and leave the output debug string just so we can continue to test. Let's do this. We're putting in an extra step here. I mean, we could directly return this. We could directly return from this function, but I'm going to go ahead and leave them as two separate steps. So from here we need to get the memory manager, right? And then from there we can call the function. We're going to add a new function called add block, and that will require we give it the size. Okay, that's going to be our hook from new into our memory management routines. Okay? All right. I think what I want to do here, guys, is right here at the top of add new pool, we're going to, whoops, that's the wrong button, put in a hashtag pragma region public functions handling pools, like pool requests. I'm going to copy this. Delete pool, delete all pools, defrag pools, query pools, right there. So we're going to end that. Oh, forgot the pragma. There we go. That way we can just collapse all that for right now. Okay, because I don't need it right at this moment. And then I'm going to put in, so align malloc should be a private function, I believe, right? It is, yeah, okay. So we'll leave that private. Oh, I just lost my... I'll copy this again. And then we'll do another one for block requests. Okay, there you go. All right, let's talk about the block requests. What do we need? And then actually here, I'm going to do the same thing, I think. We're just going to make sure things are nice and tidy and neat. So we'll do pool functions and we'll do block functions. All right. So we've already decided that we need to put in a couple of functions, one of them called add block. And that's going to take a size t, we'll just call it size. I'm going to overwrite or overload that as well and put in one with a pool ID. So this way, we'll be able to call one without a pool ID, but we'll also be able to call one with a pool ID. Because you'll remember we have multiple pools, and if we don't specify a pool ID, we'll drop into the default pool. That's how that's going to work. Okay. Okay. Then the other thing we really need out of the manager is a delete. What should we call this? Okay, and then finally, guys, we'll put in the same function again. Same thing. We'll add one with a pool ID. Pointer. It's not a particularly descriptive name, but it's the best one I can come up with for that. All right, pretty good. Let's save all that. Okay, guys. All right, let's close up this again. Why is this in the wrong spot? This is making me crazy. I wish these things would stay together. Pool. Okay, very good. Okay. Let's go ahead and grab these two functions and drop them in. And we will write these. Okay. All right, guys. So let's start off by writing the simpler one, which is going to be this one, because we have the pool ID already. So in order to do this, we need to first find that pool. So let's get ourselves a memory pool class, and we'll just call it pool. All right, so we'll find the pool with a function that we have not yet written, but which is going to be pretty simple. And then if we don't find the pool, we're going to return null pointer. If we do find the pool, we're simply going to pass through to a function that we're going to write called add block. Well, we got to write a bunch of functions, don't we? Okay, so there you go, guys. So we're going to find the pool that we need. If we don't find it, we're going to return null pointer, and then we're just going to drop into that that object and add the block. Okay, so really it's just a pass-through function in essence. So here, what I want to do, let's get ourselves a pointer. We're just going to call the other function, really. There you go. In fact, I don't need to do this. This is ridiculous. Let's stop doing that. We'll just return it directly. Like such. Okay, now we've got three functions that I've written, none of which actually exist at the moment. So let's write this one first. It's very simple. We'll make it private, and it's going to be int get default pool ID. I'll tell you what, pragma and region, such. Okay, so this is going to be a private function, so we'll put it down here. Int default pool ID. Return. I don't know what that was. Here, before we do that, let's make it part of the class. Default pool ID. There you go. All right, that's a quick function to take care of that. Let's see, let's make sure I didn't do anything funky. Oh yeah. All right, that works, except for the case where default pool ID might not exist yet. So pool ID equals -1. We're going to use -1 as the number to say that no such pool exists. If first pool equals null pointer, return -1. Otherwise, we're going to set it equal to first pool, get pool ID. All right, there you go. So it's a little bit more tricky now. If default pool ID equals -1, where -1 is the initial value of default pool ID, which I don't think I ever set up. We never really have set up default pool ID to do anything, have we? Yeah, let's put that in here. There we go. Okay, so we initially set default pool ID equal to -1. Then in the add new pool, we should be setting default pool ID well, we actually don't need to. Let me see this. Is that the only place we ever... Yeah, it is. Well, that should be fine. Whoops, I didn't mean to put it into here. Why did I do that? There we go. Okay, that should be fine. We don't necessarily need to set default pool ID in the add new pool function because it will be set down in here, or not down in there, but right here to the first pool. Okay, very good. And then if for some reason we try to do this before any pools exist, this is going to return -1, and then this will return null pointer. So we should be all right there as far as erroring out goes, I think. All right, so far so good. Okay, very good. Find pool. Yeah, let's write that one. Okay, so find pool is going to just simply return a memory pool class pointer. Based on the pool ID. All right. So again, this should be a fairly simple function. Sorry, memory manager. Let's put it here. Just copy this over. So we just need to take gosh, what am I doing? Let's grab all this. All right, so no, I don't need that. That's not what I was after. Okay, so based on the pool ID, we need to grab a pointer to the memory pool class, right? So let's get ourselves a pointer. All right. So this should be easy. We just have to search through the all the pools that we have. And this is a scan, which is, you know, you don't love to have scans in the code, but in this case, there shouldn't be a huge number of pools. If there are, then, you know, this could slow down the program, but I don't know of any other way to do this. So yeah. All right, what am I doing here? This is okay, so we'll get the pool ID equals pool ID, then return that. Otherwise, we use our linked list. Get next pool. All right, there you go. And then if we don't find anything at all, we're going to return null pointer. Okay, so does that make sense, guys? So we set the found pool equal to the first pool. That's from this thing right here. If it doesn't equal null pointer. So if it equals null pointer, it's going to drop down immediately and return null pointer, which means we don't have our first pool. But if it doesn't equal null pointer, we'll get its pool ID. And if it matches the pool ID we're looking for, we return that. Otherwise, we set it to the next pool and continue on until we find it. Or if it's never found, we end up with the null pointer again. It drops down and returns the null pointer. So that should handle that. Okay, what else do we got left? We got the actual add block. Okay. So let's make sure everything's working other than that one error. What do we got here? Oops, I got these backwards. That's the problem. That's right. Is that what I wanted to do? Yeah. Okay. Let's see if we get any additional warnings. Okay, no, that's it. Just the two errors. These are both coming from the same thing. Okay, good. Okay, gang. Let's see, how am I doing on time here? We're getting pretty long. That's okay, we're almost done. So, I mean, we put in several functions, but they're all pretty simple functions. I don't really feel the need to explain them in too much detail. I think you guys should be able to follow all that, hopefully. It's hard to explain while I'm writing code what I'm doing, but hopefully it's pretty obvious what's going on here. Okay, so in the memory pool class, we need to add this function, add block size. So let's go do that. And I'm going to kind of do the same thing I did here. So we're going to do pool functions, and then we're going to do block functions. And I need two functions basically for this. Add block, we're just going to take a size t, we'll just call it size. And delete block, which is just going to be a void. Delete block. And that doesn't need to take anything. Actually, that may need to take something, but I don't want to deal with that right now. We're not going to deal with delete at the moment. Okay, so down here at the bottom, I think. Tell you what, we'll just put in these two guys. Like such. Put in our separators. Let's put in a double separator there just so I can distinguish between the pool functions and the block functions. All right, here we go, guys. We finally have made it over to the add block function. This is going to be this is where all the work is going to happen, right? Okay. Couple things. Number one, we're going to need a pointer to a memory block class. That'll be our new block. Number two, remember when we call new, what we want to get back is a pointer to the data. So this is where we're going to set that up. So we will also set up a pointer to the data itself. Okay. So you guys remember, we took some time to set up the next available memory block. So we've already got this ready for ourselves. So the only thing we need to do really is call we'll use a placement new to call the constructor. I'm misspelling that. Constructor of the block class. Sorry, that's not what I want. So we're going to go new block equals new, and here's where we call the placement new. So next available memory block. Next available memory block of type memory block class. Yeah, like such. Okay, I'm going to change that in a bit, but for right now we'll leave it. Okay guys, so with that function, okay, we've put the memory block class, which is this one, into that spot where we had already set it up. Remember that we went through some trouble to set up next available memory block, so it's in the right spot. So here it is. So before we go any further with that, what I want to do is set up a couple of things in here. So the memory block class needs to keep track of its kind of linked list, the same way we did with the memory pools. So we'll set that up. We're going to put in a Boolean here. Optimal location. Now you remember, we're not going to use this yet, but you will remember when we delete blocks out, memory is going to start becoming fragmented, and so we need to know whether a block is in the proper place or if it's behind a fragmentation. And that's what we'll use this flag for. I'm going to be fairly easy to do. At least keeping track of the flag will be fairly easy to do. Actually, moving the memory is not going to be easy, but we'll deal with that later. And then finally, the memory block class also needs to have a pointer to its data. This is important. This is the whole point of the whole thing, right? Memory block class should know where its data is. We definitely need that. In fact, that's such an important function that I'm going to right now write a function for it so we don't forget. So let's pull that open. Where's my memory block class? There it is, way over here. Don't want that over there. Let's put it over here by this header. Oops. Okay. So we haven't set up anything in here yet, but we will. Just going to grab a separator so I can separate these guys out. Oops, I got the insert on, don't I? All right, there we go. And this is just going to return data pointer. That's all we need to do there. Okay. I think what I want to do here, guys, is set ourselves up another constructor. Only this one's going to take a pointer to the data. I'm going to put this here, actually. Nope, I don't want to do that. Never mind. We'll just do it like such. All right, so what do we need to do in the constructor of memory block class? Well, the first thing we can do is set the data pointer equal to data. Prior block equal to null pointer. And next block the same. You can set those up. Okay, so what this is doing is it's taking a pointer and just setting the data pointer to that pointer, right? So we basically have already sent this, and that in fact is what I want to do. So let's go back to memory pool class where we did that. And right here, this is what I want to change. So we will determine in here where the data pointer is coming from. So we're going to say data equals calculate next line memory. We're going to go from next available memory block plus the size of the memory block class. And then we'll use our memory alignment. So what we're doing here is we're taking our current next available memory block. We are adding in the size of the memory block class to get to the next spot past where we have the memory block class. Okay, do you guys get that? It's just taking the next aligned memory area. Now, of course, this isn't going to work because, of course, we've got to fix all this. So this is going to take a reinterpret cast to an int pointer. Like such. Yeah, and this whole thing needs to come back to a void star. So like such. Okay, so this will go to an integer. It'll add in the size of the memory block class, which is a long. This is a long, so those should add together fine. Then we go back to a void star to get the data. Okay, here we go. And then I'm going to pass that into this constructor, like such. Okay, so there you go. Great. Now the last thing we need to do at this point is in fact calculate our next available memory block. Because remember, we need to have this pointing at the next available one at all times. So we'll go ahead and do that. In fact, this calculation is going to be the same as this pretty much. I'm going to copy this in. The only difference is instead of all that, we're just going to use data. Actually, data plus the size of the data. And that should do that. Yeah. So the data is the start of the, remember, is the start of the data itself as it's aligned, plus its size gets you to the end of that data, and then you take the next aligned memory from that point, and that'll give you to the next available memory block. So that'll update that. And that should be all we need to do there. That should be good. I won't deal with delete block in this episode. We're already getting to be overly long, I'm sure. Oh yeah, geez. I should have broken this up into 2 episodes is what I should have done. Maybe I will do that. Come to think of it, this is getting to be ridiculously long. Okay, guys, that ought to work, basically. The only other thing I want to do, really, is fix this. I actually don't want them to ever call this, so I'm going to delete that out. The destructor for the moment, yeah, we'll leave that alone because I'm not sure what I'm going to do with that yet. That should error now. I feel like that should error. Why would the compiler allow that? Yeah, okay. I'll take that out. I only want them to call it with a data already in place. We don't want them to call it a default constructor in this case. Okay. Let's make sure everything is working. Add block must return a value. What did I do there? Of course, yes. Let's return the data. Okay. Let's go ahead and run it. It should work. Let's see. We don't have any testing functions in here yet. Of course, I didn't. Yes, we did not actually call it, did we? In order to do this, we need to actually do some testing. So let's do that. Let's just give ourselves a couple of variables. And right up in here, we'll say p equals new int. And q equals new. And let's make this a float, actually. Let's just give ourselves something different. And then down here, we will say delete p and delete q, like such. All right, let's actually give that a test. Yeah, before I do this, well, let's just do it and we'll see what we get. So everything ran, no crashes, very nice. Close it out. Let's see. Yeah. So here's what happens. So after we go through all of our pool adds, we do this new one is called. You can see we got an original location. Are we in 64-bit? We are in 64-bit mode. Of 150, it aligned it to 200 because at the moment our memory alignment is set to 256. So that's why it's dropping it to 200. If we didn't have this set to 256, actually it should, based on what we did prior episode, or this episode, but I think I'm going to break it into two. So the prior episode, which in the memory helper class, if I remember right, we did this, right? Yeah, it would actually leave it right where it was. But in this case, it dropped it so that it's got the double zeros at the end. Then we've got the data, which is 4 bytes long. This is correct. We used an integer, so that's 4 bytes. And then we realigned again to the next available spot. So that's great. Then we called another new. So that's at 20. We aligned it to 400. We used a float, so that's 4 bytes again. And then the next available is going to be 500. So it's actually doing what it's supposed to do as far as that goes. Okay, guys. Let's take a look at Memory Manager class real fast. I want to just see something here. Yes, okay. So we've got this. I want to show you something that's going on real fast. And I'm going to reorganize this, I think, in the next episode a little bit. But let's just quickly go over this just a bit. So we called new, and we also called delete. And now the corresponding function for this, we use the size t version of new. So the corresponding function you would think would be this one, the basic delete. But you'll notice this did not, in fact, print out. And you may be wondering, well, what the hell? And in fact, I was wondering, what the hell? I was wondering the same thing myself. Let me show you this real quick. And I think we have, if we're going to split this episode up, which I'm going to have to, I probably have a little bit of time. So yeah, I'll show you this real quick. I'll show you what's happening. Because it's not doing exactly what we expected. It should be calling that delete, right? And it's not. There you go. Delete 3 is being called. So you might be thinking to yourself, well, what the hell? We used the void P, which is kind of, let's see, it's under WinBase, right? It's not specifically put down here, but it's the compiler adds it in. That's just how the delete function works. But we did not put in a size t, so why is it calling delete 3 instead of delete 1? Well, let me show you a quick thing, guys. Okay, gang. This is the site c++.com. If you are a C++ programmer, you really need to know about this site. This is a great site. This is like my go-to resource whenever I need to look something up that I'm not really sure about, as far as almost anything in C++. But it's great for like looking up the standard for various flavors of C++. So this is the delete page. It's got 3 versions: the ordinary delete, the no-throw delete, and the placement delete. None of which actually correspond to what we were doing. This is the one we expected to call, right? And it didn't call that one. If we go to C++ 14, this is the one that ended up getting called, number 4. So why did it call 4 instead of 1? Well, it's because of this little note down here. No, not that little note. So it's actually because of this little note down here. Delete expressions that use a global deallocation function always use a signature that takes either a pointer, such as 1, or a pointer and a size, such as 4, preferring always the version with size 4 unless an overload provides a better match for the pointer type. Okay. You'll notice 2 and 3 are never called. So really it's only 1 and 4. So that's what's going on. The compiler is preferring the version with the size over the version without the size. So that's why we ended up calling that. In actual fact, look at this. Right here it says the default definition simply calls the corresponding version either 1 or 2. So 4 really just calls 1. Okay, and that's what we're going to do actually. Now, this note down here says, note that if one of the signatures with size is replaced or its corresponding version without size shall also be replaced, and the other way around. If either 1 or 4 is replaced, both shall be replaced. Likewise, if either 2 or 5 is replaced, both shall be replaced. So my initial thought was to simply, when I discovered that it was calling delete 3, was simply to remove this, and because the default version calls version, where did it go? Calls version 1. And that works, except for we've got this note that says, if you replace one, you got to replace them both. So we should do this manually. And the reason they do that, guys, is because in the future, it's not guaranteed that this version will automatically call version 1. I mean, they could change that in the future, right? So we're going to do it ourselves. So I did say I wasn't going to deal with the deletes, but this one little thing I want to deal with in this particular episode. So the way to do that, if you look back at our page again, is this. So I'm just going to copy that code, drop it here. This is P. Like such. So that will call, that should call delete 1. So let's run that. We'll just double check that that's what's happening. Close that down. Let's find our deletes. There you go. Delete 3 called, delete 1 called, delete 3 called, delete 1 called. So now delete 3 is dropping back to delete 1, which isn't doing anything right now. But we'll deal with that in the next episode, I think. Okay, guys, there you go. We have a working setup for the blocks. Let's make one more check real fast to make sure everything is working like we expect. I'm going to drop this down to 16. Let's run that. I got a warning. We'll check out that warning in just a second. Okay, so look what's going on here. We're now at a memory alignment of 16, which means there's only going to be a single 0 at the end. This was already aligned, so it didn't move it forward. So that's doing exactly what we would expect. This is C4. The next aligned memory is D0. This is aligned at F0, so it doesn't move it forward. That's good. That's what we wanted from the last episode. And then F4 to 1100. There you go. That has, in fact, moved forward by that. I want to see what that warning was before we wrap this up here. I did see a warning flash by as returning address of local variable right location. Yes, that's not going to work, is it? That's because I have that sitting there. That's not right. Okay, there you go. And in actual fact, to be honest, we don't really need to do any of this. I'm sure the compiler's optimizing that out already, but there's no point in us having all that extra verbiage in there. We can just take it, we can just do it directly like such. And there you go. Everything looks fine. Let's go ahead and just to double check. Let's go to 32-bit mode. And let's run it again. Just make sure everything works the way we expect. Okay, you'll notice the pointers are now, let's see, what are they, 4 byte long? Yeah, 4 bytes, 32-bit. So let's see, let's just double check and make sure that's doing what we expect. 68 to 70, 74 to 80, 90 to 90, 94 to A0. That's fine, that's working great. Looks like it's doing well. All right, we're good. Okay, guys. I'll probably write some code to do a little more extra double checking on that, because we got to make sure this function is working right. We don't have any problems. But it looks like we're doing fine. I don't see any issues here. And we will also, in the next episode, deal with the delete, I think. It's hard for me to judge because these episodes are taking up much more time than I expect. I was expecting to get through the last 2 episodes in 1 episode. I've been recording now for, well, I've broken it up into two segments, but this whole thing's gone almost 2 hours, which is ridiculous. So I'm going to break these into 2 episodes, which is going to be a bummer for the first episode, because I said you guys are going to get a working memory block class by the end of that episode, and it didn't happen. But we've got it now, so it's all good. I think that's all I want to do for today. Yeah, we'll deal with the deletes next time. But we should have a working system at this point. So very good. Very, very nice. Okay, guys, we'll stop here. Let me take a minute to thank my patrons. My $5 plus patron is Michael Hilliard. Thank you very much. In the description below, you will see a list of all my $3 plus patrons, along with any links that they've requested that I link to. So please do go check those out, guys, because there's some good links in there. And then finally, at the end of this episode, you'll see a list of all my $1 plus patrons. Thank you very much, guys. It is much appreciated. This would certainly be a much more difficult endeavor without your support, so I do appreciate it. All right, gang, we will stop here and we will pick this back up in the next episode. So I will see you guys in the next one. Thanks a lot. Thanks for watching, guys. If you enjoyed this video, please take a second to comment, like, and subscribe. All these things really help me out. I'd like to say a big thanks to all my patrons whose names are appearing on the screen right now. Thanks a lot, guys. I really do appreciate it. If you enjoyed this video and you'd like to see more great content, consider joining my list of patrons. There's a link on the screen in the bottom left corner. Thanks a lot, guys, and I'll see you in the next video.